So tonight, all things intended, this should be our last class Zoom session for the semester. I might come back one last time towards the end to wrap things up, but if everything goes according to plan this evening, we probably shouldn't have to. The folks that are still with us as far as doing activities in class have been chipping away, doing a great job. I don't really have a ton of other things to show you as far as teaching you with lectures and stuff. My big thing is to make sure I can show you where the different resources are for you within Canvas here. So if I turn on my drawing tool here, we can do some scribbles here on the screen. You'll notice that I have it on student view mode right now. So other than this pink border going around the edges, this should look similar to what you would see on your screen on your computers at home. So, one of the things I always want to point out, as a student, you should be looking over here. You got this to-do bar, and it shows you, what you've done, what you haven't done. And on my student mode, there's this activity that actually was due a little bit ago, but I probably didn't talk about it enough. And I do want to talk about it right now. So I'm going to click that thing and open up that activity, and I'll clear out these drawings. This assignment about setting codes and making various failures on your vehicle is really a good one to do. Now, obviously, what it's going to do is cause a check engine light to come on. And so I do have my warning, my disclaimer in there that says, hey, if your car is up for a smog check, make sure you get your smog done first, because what you're going to have to do when you're done with this assignment is eventually clear the codes. That's going to wipe out your monitors. In fact, that's one of the things we're going to talk about more this evening. But that's my little warning. It really won't hurt the car, but it will set some codes, and that could, cause you to have issues if you did this activity and then you clear your codes and you went right around the block to your local smog check station. That wouldn't be good. Okay. Now, why I think this is such a powerful activity is you really don't know how the computer in the car is going to respond to, different failures you've done until you check it out. And how the car's computer is programmed, some cars will react differently than other cars. So for example, in this picture right here, we're disconnecting a mass airflow sensor. And inside that mass airflow sensor, it's usually two sensors in one, because if I split it up, it's also going to have an intake air temperature in there. And it's going to have our mass airflow, right? So when you think of a mass airflow sensor, don't forget that usually the intake air temperature measurement is also part of that sensor. So with this activity, if you were to disconnect the mass airflow sensor, and all of a sudden the computer lost both of those inputs, some cars will maybe hiccup for a quick second, and then they won't skip a beat. In fact, what you'll find out is that a lot of cars, mostly your domestics, your General Motors, your Fords, your Chryslers, you drive them around, and other than the check engine light being on, you probably wouldn't feel that the car ran any different at all. I find that a lot of the domestics are really good at substituting values, especially for things like the mass airflow sensor. Whereas if you did this same test where you disconnected a mass airflow sensor on a Toyota vehicle, you get a vehicle that would like start and die, start and die, start and die. And then if you could get it to keep running, it would have, a severe lack of power. You might get it to idle okay, and then you go to open up the throttle and it wants to stall out. So every car, depending upon how it's programmed, will respond a little differently to failures. And the only way for you to kind of figure out what's what is to make some failures and see how the vehicles respond. And you'll see commonalities between, manufacturers on how their vehicles respond. So that's what this activity was all about, was causing you to make failures and see what happens. One of my questions, and I see G is here with us. He's done this activity and had some good data from that. One of my questions is, hey, is it a type A or a type B code? Remember, a type A code sets right away, meaning that it will turn on the check engine light right away. It'll not only set the code, but it doesn't just set a pending code, it sets a full-fledged code, turns on the check engine light right away. The vast majority of codes on vehicles these days are type B codes, because the manufacturers want to try to keep that check engine light off to keep their customers happy, right? But and so with the type B code, it would take a couple times of driving the car for that check engine light to finally come on. So this is a really just a key test to do. Now, I wouldn't drive the car a long distance. I wouldn't drive to San Francisco or something with a bunch of sensors disconnected, but you could certainly drive around the block and it wouldn't damage your vehicle. The worst thing that's going to happen is you're going to set a bunch of codes, and then you're going to end up having to clear those codes with your scanner when you're done. You also might run into a problem where maybe your car's a little bit newer and it sets those permanent DTCs. And I want to say that's what G's car did, is he set a permanent DTC, and it took him a couple days of driving the car to get that DTC to clear out. But all that, in my opinion, is just a great educational experience for you to figure out how it works. And I think it's more powerful for you guys to do it on your cars that you can drive out on the road and you can scan them with your scanner. Because with my school cars, if you're taking classes at ARC, you're taking the engine performance class or some of our fuel injection type classes, we don't get to take a lot of our cars out on the road and really drive them, run them through a drive cycle, run a monitor. And so that's why this is, a really powerful test to do. So if you haven't done it, I really encourage you to do it. It's a test where I think you will learn a lot. And it's a test that I like to do this test over and over on real cars. So one of the things that I did as a technician is, at my shop, we had an account with Hertz. And they would bring us all their used cars, because at that time, even if a car only was like 1 or 2 years old, if you were going to sell it, you had to get it smogged. So we would do a safety inspection and we do a smog test. And so I would get a lot of these cars that were 1, 2 years old. Maybe they had 20,000 miles on them. I hadn't scanned them before. They were new makes and models. And I would scan them. I would save those files. That was one of my tips for you guys, is save files on cars where everything looks good. And then I would do this test. I would make failures on the cars to see how they were going to respond, to learn what they were going to do. And so if a car like that came back, a lot of times it would be a couple of years later before I saw that car again, I could look at my notes and see, okay, how does this car respond to those things? So if you haven't done this activity, I really encourage you to do it. I think it's a real good one, and that's why I obviously put it in the class. So I'm going to go ahead and clear that out of there. We had some other activities like establishing a condition. I'm just trying to get you thinking through that a diagnostic process as much as possible. So I was, pretty lenient on this. It doesn't, it's not worth a whole lot of points. I just want you to kind of start thinking, well, how would I figure out what's wrong with that if I had, these scenarios, a car with a no start condition, and then lack of power on acceleration, right? And you definitely have to think, like, there's some common things. Like if I have a lack of power on acceleration, well, what can cause that? Well, something like a restricted exhaust could cause a lack of power on acceleration. I remember I had an old, and this is, OBD1, this is an early 80s C3. Yeah, it was like the last of the C3. So maybe an 80 or 81 Corvette that had a lack of power, and it was computer controlled carbureted. And my boss kept thinking that there was something wrong with that darn computer controlled carburetor. And I kept, trying to plead my case that I didn't think it was the carburetor. So long story short, after it got a complete carburetor rebuild and I got the car again, I ripped out the oxygen sensor and drove the car, and it had a whole bunch of power back. And so that's how we figured that out. But anyways, lack of power acceleration could be like a restricted fuel filter. It could be a restricted exhaust. It could be something as maybe you have a misfire. So it's not running on all 8 cylinders. It's only running on 7, right? Well, the nice thing about OBD2 is we have some tools there that can help us out. Like, for instance, if I had a lack of fuel, well, I would probably see my oxygen sensors and my fuel trim be affected by that. If I had a misfire, well, I might have some misfire monitor codes. And those are things that I didn't have on that old Corvette. Anyways, so this isn't worth a ton of points, but it's an activity to try to get you to think in a diagnostic process. Moving forward, we're kind of at our ending activities. And so I just wanted to point out a great way is just to go through what's on the to-do list over here. And we'll get to this one on Snap-on tools here in a minute. But another way to go about seeing what's due and what's next is to go over here to the calendar and open up that calendar so you can see what's coming up. Well, I knew that, hey, Thanksgiving holiday is coming up. You guys have busy lives. So I pretty much pushed our a lot of our remaining assignments. I pushed those back after the Thanksgiving holiday, but before the end of the semester. So you can see there's really nothing due right away, but I don't want you to forget about it. The remaining assignments come up at the beginning here of December, where we can see we have this activity where we're talking about Snap-on scanners versus others. Our fuel trim and volumetric efficiency calculations. That, of course, was our hot topic for our class last time, and we're going to talk about that again a little bit tonight. But that's kind of like your last scanner activity to do. And then, of course, you have like your final exams and that type of thing. And we're going to talk about this Snap-on NC3 certification and stuff next, okay? So that's a great place to go. And you can see that you have a few weeks, off, so to speak. And then your final assignments are due that, early December as we wrap up the class. So if you have a busy holiday season or busy Thanksgiving holiday coming up, let out a sigh of relief because you don't have to worry about this class for a little bit. That being said, what is the deal with stuff like the Snap-on stuff? Well, let me click this activity and let's open it up. We'll clear my drawings. So in this class, and this isn't something you have to do, but this is something you can do if you want to. And originally in the class, this was our entire focus. And then when we decided to make it more of an online class, we realized, well, it wasn't practical to check out these $3,000-$4,000 Snap-on Solus Ultra scanners to our students to take home. So we kind of modified things. But you guys have the opportunity to come to ARC. And I remember I'm there teaching skill and speed class every Friday. But you're welcome and invited to come to ARC on a Friday, or if you're taking any other in-person classes on our campus in the auto department. So let's say you're taking brakes class with Mr. Ha, or suspension and steering with Mr. Gunn, or a class with Miss Androna. So you're welcome to check out this scanner and kind of run it through its paces. And so this assignment just asks you a little bit, to asks you a little bit about it. It gives you kind of some information. And I actually grabbed an old red brick, and I have my own red brick, and I forget where I put it. So I borrowed, we had one of these up in the attic at the school. So I borrowed it just to show you guys. They call it the red brick because it's red and it's a square kind of brick shaped. And so here's a picture of it right here. This was a great tool, man. This came out in 1988, and I used so I bought mine used from a guy for, I want to say, $400 or $500 in 93 or 4, something like that. Probably, I think 94. So it was already kind of old, but I used this tool up into the early 2000s when eventually the vehicles computers on the cars got so fast that this tool couldn't talk to them anymore. But it was just a great tool, really easy to use. It had 2 buttons, yes and no, and a little thumb wheel here. Worked really well. But here's what made this tool great. This cartridge that would slide in like an old Atari or Nintendo game, I'm dating myself here, but that cartridge that slid in there like an old video game that said troubleshooter. Because what Snap-on did is they would put all their service tricks and tips and stuff in the troubleshooter cartridge. And so it was kind of like working next to the guy that had worked on a lot of those makes and models of cars. Like, let's say, you work pretty good on, Fords and Chevys, but you don't really get to work on Toyotas and Hondas. Well, if you had the fast track troubleshooter for Asian imports, it was like working right next to that guy or gal that was that ace at Toyotas, Hondas, Nissans, and had all kinds of tricks and tips for you to try. And so it really helped shave your time as far as diagnostics. Well, this software is built into Snap-on's new generation of tools. It's not a big cartridge that you slide in there, but that software is built in there. So that's one of the advantages of the Snap-on tools, is that their software is pretty good. It's really easy to use. It's definitely this Solus Ultra is definitely an evolution of that original Snap-on scanner, that MT2500. But that troubleshooter is really what separated them out from the other tools, especially at that time. So this assignment kind of gets you thinking about that. And the idea is to share your own diagnostic trick or tip. Because what's kind of made the troubleshooter not as powerful as it used to be is now you have the internet, right? Which you didn't have in 1990 for the general public. And so now, like, I can get on the internet, I can kind of search around, I can find people posting tips or tricks or YouTube videos. There's online communities like, and I'm going to put it up here in the search bar, the IATN, International Automotive Technicians Network, where they're sharing all kinds of technical tips and tricks and different things. And I remember joining this way back in the mid 90s, and it was revolutionary at the time. And, if you haven't got on there and cruised around, I definitely encourage you to do so. Anyways, so now it's almost like, because we have the internet, we have access to that troubleshooter type of information if we have access to a computer, right? So stuff definitely has evolved. But the idea with the assignment is to get you guys to share some tricks and tips, and that might be something that you'll do in the future as a professional technician member of IATN. And I would really, love to see one of your postings someday on IATN. So anyways, that's what that assignment is about, and a little bit about the Snap-on tools. Well, where do I find more about this Snap-on Solus, and how can I get Snap-on certified? Well, if I go here to the modules tab and I start scrolling down, and here we are in our class right here. We're in this advanced drivability diagnostics. We've been talking about things like using mode 6 and fuel trim, and in our last class session, we checked out this volumetric efficiency calculator. I'll go ahead and click it just to bring it up there. There it is. I'll go back though. So that's kind of where we're at. But once you get past that stuff, if I clear out my scribbles again, once you get past that, what you'll find is there's these modules that say Snap-on Solus Ultra Training. Snap-on Solus Ultra Training. And so what myself and Mr. McCormick, one of our other auto teachers, did is we, did the Snap-on training, and we put together a whole series of online lessons on the Solus Ultra. And so
work with controls in that.
Here's a quick, snippet of the video clip there. So we basically put together these online videos on the Snap-on Solus Ultra. The other thing we did is we put together a presentation for you guys to look at. We loaded the manual. Here's that. Here's a PDF version of the complete presentation, or part one, because it's a big presentation. So here's all the slides if you just want to go through and see the slides. And of course, some of these things look familiar because we used them in our class, right? Like our compass analogy and front door and back door and PCM. So a lot of this stuff really meshes in with what we were talking about in our class. But as you get to the more advanced sections, it gets into some of the nitty gritty of what you can do with the Snap-on Solus Ultra. And one of the things that I would recommend you do if you're interested in really, becoming a master of using the Snap-on diagnostic equipment is come into ARC, and you don't even have to hook this tool up to a car. You can go into training mode in this tool and just go through the PowerPoint or go through the videos there and run that tool through its paces. When you're all done doing that, if you've played around with that Solus Ultra, you've gone through all the presentations and stuff, what you'll see is I have some pre-tests here that you can take. And then if you're getting like A's on the pre-tests, what you can then do is go through and take the Snap-on certification test. And what I will open up, in fact, let me leave my student view real quick. What I will open up is a link here to have you do that Snap-on Solus Ultra certification on Snap-on's website on NC3. So anyway, so you guys don't have to get Snap-on certified in this class, but you have the full option to get Snap-on certified. I've actually already loaded you all into the NC3 website. And I'll put a class announcement together on that shows you what to do, because I see I'm running a little bit behind my timing of stuff. So anyway, so just don't forget, like if you want to get Snap-on certified on the Solus Ultra, you can do that in this class. And what I recommend you do is go through the videos and stuff, and then come to the college and get that tool in your hand and run it through the paces. And it has a great training mode part built into its software. So you don't even have to necessarily hook it up to a car to run it through its paces and check out its software. All right. So hopefully that makes sense. And so again, remember from the home screen, there's always the announcements. We're up to announcement number 20. You'll see a couple announcements coming up in the future that show you how to get into NC3 and take the Snap-on test and everything. And remember that Snap-on training is at those modules all the way at the bottom. All right, so what about tonight's presentation? Well, it's a good one. And so what I'm going to do is change my screen share, and we're going to open it up. So we're going to be looking at some case studies that are good ones and just mopping up some odds and ends. But we're going to start with a little review. By the way, what's on this scanner screen right here? This is a good example of the data that I would use to do the volumetric efficiency test, right? I need my engine RPM at its highest, my mass airflow in grams per second at its highest, my intake air temperature. And notice that the engine was running hot, or the air was hotter. And then as I romped, it went up to like 102 degrees here. And of course, as I floored it, a bunch of air starts moving through the air intake. And so that extra air moving through actually lowered the temperature back down. So it's at 100.4 degrees. So these are my readings that I would put in my volumetric efficiency calculator, along with knowing the size of the engine, right? What its displacement is to get me those VE numbers. All right. Let's jump in here. So we started our semester talking about the history of onboard diagnostics, right? Our OBD evolution, if you will. When we started in the 1980s, you know, everybody was all over the place. I will say that GM systems had about the best diagnostics around. So I'm going to put GM for General Motors, and I'm going to put a star next to those guys, because those guys way back in 1982 would give you scan data and trouble codes. They were just really, you know, way far ahead as far as self-diagnostics on their OBD systems. By the mid 80s, we went into fuel injection. And of course, in California, we were doing our 2-speed idle smog testing. And what we saw is our emission requirements ramped up. That led us to the standards in 1988 that became OBD2 in 96. And I was there on, you know, at the ground floor for this thing, working as an entry-level technician and wondering how are we going to deal with OBD2. So we started our class really kind of going through some of the history of this process. And I always feel like if you look at the history, if you know where you've been, it kind of makes sense of where you're going. So if we keep moving forward here, I beat you up with this analogy several times, right? Your scanner is your directional tool, like a compass. A lot of times it'll get you close, but you're still going to need your multimeter, whether it's an inexpensive one like this or a full-fledged oscilloscope. You're still going to need something like that oftentimes to pinpoint exactly where the problem is. Okay, so the scan tool doesn't replace everything. I see way too many people get a code for something, they pull the codes with their scanner, and they just start throwing parts on their car. All right, moving right along. We then got into the different modes of OBD2. And so you can see that there's 10 modes of OBD2 these days. And this is that hexadecimal language there, right? We've been really focusing on modes 1 through 4, but we did talk about the other modes in our class. And I do feel like if you can, you know, take advantage of all these modes, even on your generic scanner, you can do some pretty powerful diagnostics with that. Okay, so for instance, like mode 8, usually it's an EVAP system test, but that's a great test to do. If you're setting a P0, 440 code, that would be a great test to be doing. So, all right, so we then went in our class and we started beating you up with this diagnostic process. And I just can't stress enough how, the scan tool doesn't replace your knowledge, right? It's really a combination of you using the scanner to its maximum ability and using your service information. And there's a reason why we don't, clear the codes until we've performed our repairs, and then we verify those repairs, because we want to make sure that we really, truly do fix the problem on the vehicle. And sometimes these vehicles can be pretty tricky with their diagnostics. So, don't forget this basic process of verifying the complaint, pulling your codes, always recording stuff, like writing down your information. That's what you want to do when you're trying to diagnose a modern vehicle. We talked a little bit about communication protocols. Remember, everything these days is going to be CAN, controller area network, and that's a high-speed communication. But there were some other communication protocols used in the 90s and early 2000s. Our little tool will tell us that oftentimes on that main screen right there. And we talked about one of the advantages of making the custom data list is you can speed up the data refresh rate, which is really nice to have when you have a slower baud rate of your communication protocol right there. And that's really good stuff to know if you ever have a scanner that doesn't communicate correctly and you're fighting that communication problem. And then don't forget, whenever possible, record your data, right? I don't want to see you guys get in a car wreck because you're so busy looking at your scanner screen. Always go down here and, you know, select that icon and do that data recording, because it's really going to make your life a lot easier and a lot safer. And even our little cell phone based app with our little ELM interface, we can do some good data recording with that. Okay, a couple things we talked about early on in our class that I still think are very, very important that not enough people really understand is these definitions, enable criteria. With OBD1, you didn't really have enable criteria, but with OBD2, you had these things called monitors, and they had to see a specific set of necessary conditions to get the computer to test itself out, right? So enable criteria is your conditions necessary to run a monitor, run a self-diagnostic test. And that's critical. And what we tend to look at is look at the freeze frame, and that will kind of let you know what the enable criteria is. If you're in doubt, look it up, you know, in your service information. The other thing is the trips versus drive cycle discussion, right? A trip is you meet some enable criteria and you run one monitor, one diagnostic test. A drive cycle is a special way that you can drive the car to get it to run all the monitors and test all of its systems out. And oftentimes that requires you to drive the car a special way. You might even have to put it on a dyno or something to do that. All right. And hey, I see on the chat, pre-test 3 was closed. I'll make sure with the Snap-on scanner training, I'll make sure I'll get those things open. I obviously got to double check them, and I'll get all those things open. And when I get it all fixed up and ready to go, I will send out an announcement for you guys, definitely. So just want to let you know, I saw the chat and I'll take care of it. So again, trips and drive cycles. Usually I'm not doing a drive cycle on cars that I work on. I'll do a trip, and that trip is always going to be related to whatever code I was fighting on that car. All right, we'll clear that out. Keep moving forward. So we beat you up with codes throughout the class. And of course, one of our big advantages of OBD2 is this kind of generic alphanumeric system. So we know a P0304 is a misfire on cylinder 4, whether we're looking at a Chevy, Ford, Dodge, Toyota, whatever, right? Now, keep in mind, we still have this whole type A and type B codes thing, and it doesn't really tell us, oh, this is a type A code or this is a type B code. What we do know, and I was talking about this earlier tonight, is that a type A should set with the first problem that it sees, right? The computer sees a problem, uh-oh, something's wrong, turns on the check engine light. Normally, the only types of codes that would be a type A code would be a misfire or fuel trim code. Most codes, by and large, most all codes are type B. So that means it's going to have to see the failure happen 2 times before it will turn on the check engine light. It'll set a pending code the first time, but it won't turn on the check engine light until it see it fail 2 times in a row. And so that's why cars don't turn on the check engine light right away. And I see this happen all the time. Somebody, they think they've done a repair, they clear the codes, they drive the car around the block. Heck, they probably didn't even meet the enable criteria. But even if they did meet the enable criteria when they drove around the block, if they didn't check for pending codes, they were just looking for a mill, well, they could have missed it because it could set a code and you wouldn't see that mill come on because it's a type B code. So remember, when we talk about verifying your repairs, what I would do is I would drive the car after my repairs, whether I was replacing something like an oxygen sensor, a catalytic converter, EGR valve, and whatever I was replacing on that car, I put on my new parts, and then I would drive the car meeting the enable criteria. So I know the monitor had ran. I would check to see, did the monitor run? And I'd look at that monitor status. Okay, the monitor ran. And then I would check for pending codes. And if I had no pending codes, I would know with pretty good certainty, hey, I fixed that issue. And if I really wanted to see, not only did I pass my test, pass my monitor, but I could look at that mode 6 data, right? So here we can see, here's some information here. We have a P0301 misfire cylinder 1. And so you look at pending codes. Oh, I got some fuel trim problems. Well, could these be related? I certainly think they are. Look at that short-term fuel trim. He's adding a ton of fuel to this thing. He knows he's lean. He's adding fuel. I could be just not giving the engine enough fuel. That's why I have a misfire. Maybe I have, clogged fuel injectors or something, or a vacuum leak or something that's causing me to not get enough fuel in there in proportion to the air that's going in there. And that's what's causing that misfire, right? So we always want to check not only for codes, but for pending codes. Okay. In the last few classes, we talked about open loop versus closed loop, and how once we start looking at this oxygen sensor and adjusting what we do with the air fuel mixture based on what the O2 sensor says, well, that's closed loop, right? And that's what we're going to run as clean as we can because we're responding to the O2 sensor or the air fuel ratio sensor, right? And that fuel trim that we look at, that is that amount of correction that we're doing based on what that air fuel ratio sensor or what that oxygen sensor is telling us. And, those old GM cars, I told you earlier, they were, miles ahead as far as diagnostics. Believe it or not, GM had fuel trim way back in the 80s on their fuel injected vehicles. They called it integrator and block learn. So integrator was your short-term fuel trim and block learn was your long-term fuel trim. And instead of them saying 0%, they would say 128 was their normal value. So if you were at 128 for both integrator and block learn, you had 0% fuel trim going on. And remember, fuel trim is telling, do I have to add fuel or do I have to take fuel away? So if something is making the engine run lean, I'm going to have to add fuel to get it to run correctly. If something is making the engine run too rich, right? Like maybe leaky fuel injectors or a blown out fuel pressure regulator diaphragm or something, then it would have to take fuel away to compensate for that. Okay, so fuel trim, very powerful data PID in our OBD2 data. Okay, hey, back to that numbering system. Remember, we looked at this one, the lean fuel trim codes, and that could be something as like a restricted fuel filter could cause this. A deteriorated oxygen sensor could cause this. But we also talked last week about the fuel map and what's programmed in the table and some fuel trim diagnostics. So remember, if you're setting fuel trim codes, you always have to ask yourself, hey, can I believe the O2 sensor or air fuel ratio sensor? I remember what I told you is, hey, physically make it run rich. Give it some carburetor cleaner down the intake or some propane. Give it a vacuum leak. So force it rich, force it lean, snap the throttle. That should make it go rich. So force it rich, force it lean, and test that O2 sensor or airflow ratio sensor to see if it's responding correctly. If you can believe it, then you can move forward in your diagnostic. If the O2 sensor isn't responding, then I might, need to be doing more O2 sensor diagnostics, and maybe that's the cause of my failure, is the defective O2 or airflow ratio sensor. Remember that those sensors do have a lifespan to them. They do not last forever. We talked about O2 sensors a little bit. We talked about how they're like a little battery, and that most of them produce a 0 to 1 volt signal. And when you're getting pretty close to a volt, that means we're running rich. And when you're down close to 0 volts, you're running lean. Air fuel ratio sensors are a little bit more complicated. They're kind of like an O2 sensor within an O2 sensor. And so with that, we talked about how their voltage ranges can be quite a bit different. One thing that you do commonly see, though, with these sensors is that they run super hot. They run double the heat. They run in the neighborhood of 1200 plus degrees. So they tend to eventually burn themselves out. And sometimes they get themselves really stuck in those exhaust manifolds. So they become really hard to get out. And I've had some cars where I just had to replace the whole exhaust manifold with the air fuel ratio sensor, replace both those items to get the car fixed. So anyways, with air fuel ratio sensors, I tend to rely more on the air fuel ratio monitor. Seems to give me pretty good data on them. And I always test to make sure that I have power and ground to the heating circuit and that the wiring is good. And if I'm setting codes for the air fuel ratio sensor and it doesn't respond to rich or lean conditions, it's a pretty safe bet that the air fuel ratio sensor is at fault. So, all right. So lastly, we talked about this volumetric efficiency thing. And remember, what you're doing is you're comparing, how much air could theoretically enter the engine. Well, that's based on its displacement. So if I have a 5.7 liter Chevrolet engine, if it was running 100% VE, 100% volumetric efficiency on its intake stroke, it would bring in 5.7 liters of air and then push those out, right? Well, we can calculate this with our scan tool based on the mass airflow sensor. And we looked at, here's the website link to do that. And of course, I showed you earlier tonight where it was on our modules and stuff to link over to that. Super useful. I find it very nice for diagnosing mass airflow sensors that are getting a little bit contaminated and misreading how much air is actually going in the engine. So there's that table, and we talked about those contaminated mass airflows. And I also said, hey, be really wary of these aftermarket air filters. A lot of these air filters, in order to work properly, you have to oil the filter, and the oil on the filter will wick off of there and get stuck to that hot wire of the MAF and throw off its readings. Even stock paper filters, what I find is little bits of paper will eventually rip off that filter and get stuck to the hot wire and eventually contaminate that sensor. So contaminated mass airflow sensors is a real thing. Okay. Hey, back to these trouble codes again. Of course, we said, hey, that's a misfire on cylinder 4, right? That P0304. Well, how do we monitor for misfire, really? That is something we haven't talked about. So we need to do that. I can't let you get through this class where we've been talking so much about OBD2 diagnostics without talking about Misfire Monitor. Before OBD2, the computers on your vehicles did not check for misfires. After OBD2, they started checking for misfires all the time. In fact, your early OBD2 vehicles, like I remember your 96, 97 GMs, seems like they were setting misfires right and left. It was really problematic. And what most manufacturers did is they had to bring the customers in and reprogram their computers, reflash them So they weren't so sensitive to misfire, because we found all kinds of things like, hey, if somebody's running their car out of gas because they drove too long before going to the pump, it would start to run poorly and misfire because it was running out of fuel. And so they evolved over time. And now some of the enable criteria for Misfire Monitor is, hey, if the gas gauge shows that it's on E, I'm going to turn off Misfire Monitor so I don't set false misfire codes. Also, if I get erratic wheel speed sensor signals coming in from my ABS system, like I'm driving off-road or over train tracks or a lot of potholes or something, that can throw off Misfire Monitor. And so we'll turn off Misfire Monitor for that as well. So 301 would be a misfire in cylinder 1, 304 is a misfire in cylinder 4. You get the idea, right? But how does it work? And again, could these things be related? They certainly could, right? We were talking about how if I didn't give the engine enough fuel, it could misfire just because I'm not giving it enough fuel to support good combustion. So don't overlook that as well. You could have a lean condition causing a misfire. So it's not always a spark plug or a spark plug wire when you got a misfire going on. And so that's why if you have misfire codes, also look at your fuel trim as well. Look at what your O2 sensors are telling you. All right. But again, how does it monitor for misfire? It monitors for misfire off of the crankshaft position sensor. So it doesn't matter if it is a digital sensor, which would be like a Hall effect is what that says there, or if it's an AC type of sensor, like a magnetic sensor here. What will happen is if the engine is running down the road, and let's say that the throttle is being held steady, I should have a nice even signal coming off of the sensor. If I have a misfire, every time the cylinder comes up that's supposed to burn its air fuel mixture, if it doesn't, right, if it misfires there due to a defective spark plug, a bad coil pack, whatever, instead of the engine speeding up a little bit after that cylinder fires, it's going to slow down. So what will happen is you'll end up where it goes up, it fires, and then it kind of slows down, and it takes longer before it gets to the next one. And the computer can then see that and go, oh, the crankshaft is slowing down right after cylinder 7 in the firing order, because the firing order is programmed into the computer. So it looks for that gap of where all of a sudden it slowed down, and then it looks at the firing order, and it looks at, well, it's not just what the crankshaft position sensor is saying, but what's the camshaft position sensor saying? So it looks at crank versus cam versus what's going on with the frequency. And from there, it can figure out where there's a misfire happening. That's how most all misfire monitors work. There was a few cars, I want to say Saab looked at spark plug ionization, but most everybody looks at crankshaft speed coming off the crankshaft sensor, synchronizing things to the camshaft sensor, and then comparing that to the firing order. Okay. So again, you could see if I'm driving off road and the engine's shaking around, that could throw off the frequency coming off this sensor a little bit and maybe set some false misfire codes. So this is how stuff gets related, right? You could have a defective wheel speed sensor, which you'd think, hey, that shouldn't affect my engine at all. But that defective wheel speed sensor prevents Misfire Monitor from running. Maybe you also end up with a bad spark plug wire or something. It never sets a misfire code. The car is running poorly. The customer comes in for a lack of power. You find, hey, this thing's got a misfire. And well, why isn't it setting the misfire codes? Oh, because of that wheel speed sensor. So with OBD2 and with the programming that's involved there, stuff that wasn't related before is now related. And that's just gotten that much more so as cars have gotten more and more modern and have multiple computer systems that are all networked together. We see weird things like that all the time now. So now you know how Misfire Monitor works, and sometimes it's fantastic, and sometimes it's a real pain. I will say that I spent hours and hours and hours looking at ignition scope patterns. After Misfire Monitor on OBD2 got really good, it's very rare that I look at ignition patterns anymore, especially on an OBD2 vehicle, because I can rely on Misfire Monitor. For example, let's say I was setting, and I'll go back a couple slides here. I was setting this P0301 code, right? This Misfire cylinder 1. I could take the spark plug out of cylinder 1, and I'm going to throw it on cylinder 2. And then I'm going to, go drive the car around. If after a drive where I have a chance to run Misfire Monitor and now it's setting misfires on cylinder 2, I can see that my misfire followed the spark plug. I know, hey, I got a defective spark plug. So a lot of times what techs will do is I'll play, mix and match spark plugs, mix and match wires, mix and match ignition coils, especially on Fords, and they'll find their defective parts that way utilizing Misfire Monitor. And that's something that we couldn't do in OBD1. So we were looking at scope patterns and all that other type of stuff, doing a manual power balance. All right. So the other thing that we talked a little bit about earlier tonight that I do want to drive home to you guys is smog testing. So my warning was, hey, don't, clear all the codes and then go get your car smogged. Well, why is that a big deal? Well, if I look at my scanner here, what I can see is that here's all my monitors here. And what you can see is most all of them are completed. Now, some of them don't apply. Like this car doesn't have a heated catalyst. You always see that one and you go, that's a weird one. Who the heck has a heated catalyst? It's my understanding that some late 90s BMW 7 Series had a heated catalyst on there. So the cat will get heated up and ready to go a little sooner and lower their emissions just that much more efficiently on a cold start. So that one doesn't apply. So this is not available completed, right? Maybe this car doesn't have an EGR system, so not available completed, right? But what you'll notice is all the ones that are available on this data stream, everybody that's available here says, okay, he's completed, he's done. He's completed, he's done. The only monitor that hasn't ran on this particular car is the EVAP system. And on, most cars, you could go in and get a smog check and this would pass smog because all the monitors have ran except for one, right? So that's okay. There's 0 codes stored in the computer. This is technically mode 1 of your OBD2 system, and you'd be ready to get the car smogged. But guess what? If I went forward and I said, you know what, I'm messing around on this thing, and here's some of my mode 6 data, so you can see it's passing its TIDs and SIDs. But let's say I'm doing something on the car and I decide I need to clear the codes. What happens 9 times out of 10 when you clear the codes is that you lose all your non-continuous monitor. Obviously, we know we're going to lose the freeze frame. Okay, but we're going to lose the status of our monitors. So that car that we were just looking at that had ran almost all of its monitors except for EVAP, if I go through and I clear the codes, all right, I cleared them. Now I can see, boom, there's a lot of stuff that now needs to be tested. Now, again, I'm in the emissions test mode of the scanner, so it looks a little differently. But what you can see is AC refrigerant, it doesn't have a monitor for that, so it just says passed, but I'm drawing a line through it because it doesn't really count on this car. It doesn't have that heated cat. Didn't have EGR, so I'm crossing those out. So a bunch of those guys that said passed now say not passed, not passed, not passed. So now I have to drive the car a whole bunch and try to meet enable criteria to get the monitors to run, to get these guys to switch from saying not passed to passed before it will pass an emissions test. Okay. So that's a big deal. And that's something that wasn't the case before OBD2 and the way our emissions program has evolved. In fact, you know, cars that are newer than 2002 in the state of California, well, we don't even measure the tailpipe emissions anymore. We're totally relying on our visual inspection and this feature of the OBD system with the thought that, hey, if it's passing all the monitors, the emissions of the vehicle have to be low. So this is crucial. So you really, you know, you need to drive the car around enough to get all the monitors to run. So that's what I mean why you don't want to just blow the codes out of there or disconnect the battery, because boom, you lose all the non-continuous monitors, and that alone would cause it to fail emissions inspection. Okay. So just wanted to drive that home. So what do I got for you to finish off our class discussion? A case study on a 2004 Land Rover. Now, this is a car I worked on a number of years ago. This car at the time was owned by our Greater Sacramento New Car Dealers Association executive, okay, the head of our board. And so the person that owned this car was a pretty important person to us. The Dealers Association supports our school very well. They hire a lot of our students, and they give us money for tools and equipment to keep our facilities up to date. And so when they came to myself and my colleague, and they said, hey, you know, I got a check engine light on my Land Rover. And of course, typical thing, just like everybody, it's up for smog check, and oh, it's failing smog because it's got codes and the check engine light's on. What type of code is it setting? It's actually setting a transmission code of all things. It's not setting an engine code. It's setting a transmission code. The fact that it's setting that code and the check engine light or mill is on, that itself is a smog check failure. Well, the car actually ran pretty good. In fact, the owner of the car, you know, had been in the car business their whole lives, and they knew that, okay, the car doesn't feel like it's running that bad. It doesn't feel like it's got a transmission problem. But they took it to their local transmission shop around the corner from the office that they worked in, and because it had a transmission code, and the transmission shop said, "Oh, it's got a transmission code. It's got to be slipping because that's what the code says, and so you need to rebuild that transmission." But the owner of this car felt like, hey, I've had cars with a slipping transmission, and this doesn't feel like the trans is slipping. Something doesn't feel right. So they bring us the car to look at for a second opinion. And we want to give them a good diagnosis because, again, they're important. They're an important person to the school. Well, again, this is the car. It's a 2004 Land Rover. I'm not a Land Rover guy. My partner, John, he's not a Land Rover guy. Like, we don't have good coverage for Land Rovers, especially back then. We didn't have really any good European scanners at all. So we were limited to a generic scanner. So at the time, we didn't have, this is probably 2006 or 7, maybe. We didn't have scanners that you could use a cell phone interface. Like, phones weren't that advanced, right? The iPhone wasn't out yet. But we had our Snap-on scanners, and we had OTC scanners and stuff, but we didn't have anything that was specific to Land Rover. So basically our scanners were the equivalent of your generic scanner. So we did all the normal things, like we checked the transmission fluid, the condition seemed good, the color looked good, it smelled fine. It also didn't feel to us like the transmission was slipping at all. But here we were, you would clear this code, you'd drive the car, a ways, and guess what? It would set the code again. So it definitely, there was something wrong in there, or at least the computer thought that there was something wrong with the transmission. And my partner at the school, he's like, well, I could put a rebuilt transmission in there, but a rebuilt transmission for a Land Rover isn't cheap. And I sure didn't want to be the person that would have to tell our customer here that, hey, we put this, $8,000 transmission in your Land Rover and it's still setting that code. So before we started to drop a lot of money at this car, I wanted to be sure. Well, about that time, something came out on the automotive market that was pretty huge for us in our industry. Earlier tonight, I showed you IATN, the International Automotive Technicians Network. Kind of an evolution for that you would have to pay money to be a member of was Identifix. And so it was all those tricks and tips for different things. And so we started a trial subscription for the college. Somebody who was a European car specialist had made a posting that said, hey, on this Land Rover, the transmission control module, so the computer for the transmission, it uses the mass airflow sensor to determine engine load. And it uses that engine load input in combination with the input shaft speed and the output shaft speed sensors to determine if the transmission is slipping, because that's the codes it was giving us as a transmission slippage code. And what it basically did, if I'm going to do a really bad drawing. This is triangular looking pieces, my transmission. Here's my torque converter. And of course, I have a couple of sensors. I got one on the output shaft and one on the input shaft. And so what would happen is, let's say I'm in fourth gear at a 1-to-1 ratio, it would look at the speed of the input shaft, right? Or it could look at the speed the crankshaft position sensor for that matter. And we look at the speed of the output shaft, and of course they should match up. If they did match up right, it would say, hey, I'm slipping. Well, it's a little bit more complicated than that, because it would actually look at like how long did it take to shift gears and calculate based on the load, how much slippage should it have and all this type of stuff. But the tip was, hey, what sensor is the computer for the transmission looking at? He's looking at the mass airflow sensor. And guess what? I had tested with an oscilloscope the input shaft speed sensor, the output shaft speed sensor, and I was pretty confident there was nothing wrong with those sensors or the wiring coming from those sensors. So it used those sensors, stuff that's programmed up in lookup tables in the computer, and the mass airflow sensor. So I thought to myself, well, maybe there's something wrong with this mass airflow sensor. Even though it wasn't really setting, it wasn't setting fuel trim codes or anything else, the fuel trim was a little bit elevated. At the time, we hadn't figured out the volumetric efficiency calculator, by the way, that would have nailed it. But we didn't know about that yet, because this is back in 2007 or so that we were fighting this thing. So the long and short of it is we decided, hey, we're going to try it. So identified the mass airflow sensor. What I did is I used some cleaner to clean the mass airflow sensor. Now, like I've told you guys, I'd always recommend using actual mass airflow sensor cleaner. If you put brake cleaner on there, it will destroy the sensor, okay? At that time, they didn't make this cleaner. So you know what I use? I use brake cleaner. But after I use that brake cleaner, guess what? For a short period of time, the transmission slippage code went away. And the fuel trim was perfect after I used that brake cleaner. Now, so I felt pretty good with that, okay, really it was the mass airflow sensor. And we put a $300 or so mass airflow sensor on the car, fixed the problem. So transmission slippage code wasn't related to the transmission at all. It was the mass airflow sensor. And I couldn't have done that without, service information and my scanner and really thinking about it. And And so it's really a combination of those things, and applying your diagnostic smarts and researching stuff. That's going to, that's how you're going to be able to diagnose, vehicles with complex issues these days. So anyways, that was a fun diagnostic. It made us look like heroes to the chair of the Car Dealers Association, and that diagnostic was probably worth, thousands and thousands of dollars worth of tool and equipment donations over the years to the college. So anyways, now we could have diagnosed it a little bit faster because we know more now. We could have done that volumetric efficiency calculator like we talked about in class and identified a shifted mass airflow sensor much, much easier. But perfect example. And of course, if the transmission shop had put in a new transmission or rebuilt it or whatever, they would have done all that work, thousands of dollars of work. And guess what? It still would have set the same code because they didn't actually fix the problem. And I've seen stuff like that happen over and over again. They'll put that transmission in the car, they'll clear the codes, they'll drive it around the block. Oh, it doesn't set the code anymore. They think they fixed it. They give it back to the customer, and it takes several days, even maybe sometimes a few weeks for that customer to meet the enable criteria. And then they come back with the same problem. So anyways, always verify your repairs, always use your service information. So with that, we will wrap this up. So what are my conclusions? Well, you always want to leverage as much information as you can from your tool, right? And that's been the theme of our class is whatever scan tool you have, whether it's a Snap-on Solus Ultra, whether you bought some real slick new Altel, those are nice tools that are out on the market these days, or a factory tool, or your little cell phone ELM interface. Try to get the maximum amount of usage out of that. Read the owner's manual, play around with it, scan cars that don't have anything wrong with them just to learn that tool and learn those cars. Use all the modes that you have of OBD2. Build custom data lists so you can look at just what you want to look at. And of course, always try to leverage your O2 sensors and your fuel trim to help you establish a condition. Am I running rich or am I running lean, right? In certain situations like lean fuel trim codes, that VE calculator can be super useful. But at the end of the day, you guys and your smarts are the best diagnostic tool that you could have, right? So I encourage you, to take more classes and training as you go through the program at ARC. And then, once you get through the program, like I'm always going for update training and other things. I just did a couple webinars earlier this month to get some update training on engine building of all things. So anyways, one thing I like about this industry is you're going to constantly have to learn new things as they come out with new makes and models and new technologies. And that definitely keeps it challenging or makes it challenging. But for me, that keeps it interesting. So with that, I hope you guys enjoyed the class. And I look really forward to seeing your last few activities here on Canvas, doing those few last assignments. Most of you guys have been doing a great job getting really high score on your tests and stuff. So again, I will get that Snap-on training information loaded up. And when I do that, I will put a class announcement up about it that has all the instructions. I'll make sure all the pre-tests work. And my advice for you is that once you get to the point where you've gone through the Snap-on training and you can get like a 90% or better on all the pre-tests, then you're ready to go to NC3's website and take the actual Snap-on certification test. If you're only getting like a C on the pre-test, you're not ready yet. You get to the point where you're confident enough on the pre-test where you can take them, and I have it set up where you can take them over and over again, where you can get an A on the pre-tests. Now you're ready to take the actual test on Snap-on's website, NC3. Okay, so hopefully, you guys will go through I look forward to seeing great scores on your final exam in the class and to see some of you guys who are interested getting Snap-on certified. Before I let you go, do you guys have any questions for me? Okay, the question is, what scan tool do you think is ideal? Man, that's a tough one. It kind of depends on what you're doing. Okay, like, gee, if you were going to be scanning a bunch of older OBD1 cars, it's hard to beat. If you could pick up a used red brick, that would work really good for scanning those old cars with troubleshooter cartridge and stuff. You know, the Snap-on stuff is nice. It's got really good software that's easy to use, great accessibility. It's also very expensive. The scanner that I see that's really powerful, that's also getting very, very popular, that's on my list to buy for ARC is the Autel. And of course, what's difficult is Autel makes all different types of models of scan tools, right? With different levels of diagnostic capabilities. But Autel sells a unit that's $2,000-$3,000, and it does a lot of diagnostics, a lot of bi-directional controls where I can take the scanner and use it to control things on the vehicle. So that's probably one of the most popular scanners I'm finding in shops these days, is that Autel. And I'll go ahead and see if I can search one out here. So the one that was really like the top of line one was that the Maxi DOS, and now they have a Maxi Sys. And you can see that, you know, some of these Autels are not super expensive and they do quite a bit of diagnostics. So I would look at like what features, but it seems like every shop I go to these days, if it's an independent shop, they will usually have some form of Autel tool there for them to use. So used to be every shop had a Snap-on scanner in it. I would find that, you know, now just as many shops have an Autel as have a Snap-on. I would say that the software of the Snap-on is a little bit easier to use, but the Autel is a lower entry price point, and it does have really powerful bidirectional controls. That being said, when you're going to be spending, you know, $1,000, $2,000, $3,000 for a scan tool, I would want to try it before I buy it, right? So, you know, I definitely would try to run it through its paces. So I recommend that you use all the scanners that you can get your hands on here at the school and try them and see what they do. I'm going to be getting a couple of these guys for the school here pretty soon. And you guys can, you know, try all our stuff out and you know, talk to technicians in the field, talk to your friends, and you'll have to make that decision for yourself. But I will say that there's a lot of these out in industry. There's a lot of Snap-ons out in industry as well. You know, and each tool has its, you know, advantages, disadvantages in it. So anyways, good question. So with that, again, I hope you got some stuff out of the class. This by no means is a replacement for the engine performance classes that we have at the college, but it should give you a good foundation in scanners and a little bit of a foundation in diagnostic strategies and stuff, and definitely how OBD2 works. And I think that will put you further ahead when it comes to scanner diagnostics in all the ARC classes as you go through things. So I appreciate you guys hanging out with me. And with that, I'll let you go. Thank you for hanging out with me this evening, and I hope you learned a lot.